We're asked to evaluate this integral. First of all, I'll do the first one. Want to get a formula for any integral of that form. So let's start with the first one, which is plus. So from our integral, this is a trig substitution question. So let's look at the table. We have three different forms. So if we have a squared minus, that's the constant is subtracting, we substitute s as a sine theta. If we have addition, we substitute x as a tan theta. If it's subtraction, we substitute a as sec theta. So let's substitute. So we'll let x equal to a, since we have plus tan theta. So if we differentiate the x over the theta, if you differentiate tan, you have sec squared theta. So the theta, I will divide it into 2. So now instead of this, we have a squared tan squared theta, because that's our x squared plus a squared, and instead of the x, we have a sec squared theta d theta. So this is now, we'll factor a squared, we'll have 1 plus as 1 plus tan squared, or tan squared plus 1, a sec theta, sec squared theta d theta, and square root of a squared is a, square root of 1 plus tan squared is sec squared, so we have sec theta, a sec squared theta d theta. So this is now a square, you factor the constant, we have integral of sec cube theta d theta, and we have a special, we've derived integral of sec cube theta. So the integral is always half, I'll prove it later, half tan theta sec theta plus ln sec theta plus tan theta. So that's the integral plus k. I'll prove it later. So we have, remember this half is affecting our, so evaluate the integral of sec cube x. So the best way to solve this is using integration by parts. So let's start. You know that sec cube x will be written as sec x times sec squared x. Because for us to use integration by parts, we need to have a product. I'm using the formula for integration by part, that's the integral of u dv is equal to uv minus integral of v du. And in choosing which one is u, how do? You use this acronym REATE, or maybe let's use LIPTE. This means log function. So if you see a log function first, we use, that's our u, we'll assign it to u, I inverse log P is polynomial, T is trigonometry, so E is exponential function, exponent. So but in this case, both of them are trig functions. So meaning that one is u, one is dv, and it seems since we have a derivative, sec squared is the derivative of time, so it's better we assign we assign u as sec x and dv, so which implies that u is sec x and dv is sec squared x dx. So in this formula we need to get v. So how do you get v? You integrate dv, and to have du we differentiate u. So we have du dx is tan x sec x. That's the derivative of sec. So du ds will make it the subject. We'll make du the subject of formula. So we have du is tan x sec x. Y v. If I integrate sec squared, I have tan x. Therefore, we now have integral of sec. Remember, this is sec cube x. Is now u. My u is, I'm using this formula now. This and this are the same, so I have to use this back because I will use it later. Our u is sec x, so I have sec x, and our v is tan x minus integral of v is tan x and du is tan x sec x dx. So which is, okay, let's write tan first. I have tan x sec x. Why? This is integral of tan squared x sec x dx. Again, to make it easier, we use identity. If you could remember that, tan squared is sec squared minus 1 using Pythagorean identity. So I have this is integral of sec squared x minus 1, which is tan squared x times sec x dx. So this is tan x sec x minus integral of sec cube x dx. Let's just write minus sec x dx. So if you notice, we'll still have sec cube x. Remember, there is sec cube x here dx. So what do? We need to use logic. So this is now, we can split this as tan this integral, integrating both, which is minus integral of sec cube x dx plus integral of sec x dx. They are the same. We are correct. So why we do this? We need to make this, because I have sec cube x here and I have sec cube x. We'll make it the subject of formula. So this comes over here. This is sec cube x dx. This is the first one. Why this is that same sec cube x dx. So we'll repeat this, tan x sec x. Why integral of sec x is ln sec x plus tan x. I've done it before. So plus k. So sec cube x plus sec cube x, they are the same, so 2. So we have 2 integral. So which implies that if I now make integral of sec cube x dx the subject of formula, remember this plus this is 2 integral of sec cube x. We now have half, as dividing both by 2, now half of tan x sec x plus ln sec x plus tan x plus k. So that's the answer. Half of this half is affect, so we'll bring out the half. So we'll have tan theta sec theta plus ln sec theta plus tan theta plus k. So to complete this, we need, because they gave us x and a, we move it to theta. So using triangle, right angle triangle, we see that since tan is x over a, sec is 1 over, let me just draw the triangle. Okay, since tan is x over a, meaning this is theta, tan is x over a, so this is now square root of x squared plus a squared. Sec is 1 over cos, so meaning that cos is adjacent over hypotenuse, so this is x squared plus a squared over a. So let's continue. So we'll have a squared over 2 tan theta is x over a, so let's replace tan theta with x over a, so this is x over a. Y sec is square root of x squared plus a squared over a plus ln sec is square root of that plus x over a plus k. So we still go further. This is a squared over 2. We have x times s squared plus a squared over a squared plus, the LCM is a. So we'll bring the two together, and a is a constant, and ln of constant is a constant, so we just write x squared plus a squared plus x, square root of that plus x. Plus x plus k, that's the ln a. Should have been minus ln a, and since logarithm of a number is a number, that is a constant, so we added it to this other. So that's our answer. So let's do for subtraction. So that same way, but this one will substitute differently. We say let x, since we have minus, is now a sec theta. Yes, if you see our table, a sec theta. So we'll go back. So instead of writing square root of x squared, I have a squared sec squared theta. And if we differentiate this, I have a tan theta sec theta. That is the derivative of sec. So instead of writing, okay, this is minus a squared before dx, which is a tan theta sec theta d theta. So we have integral, we'll factor a squared, we have sec squared theta minus 1. Why this is a tan theta sec theta d theta. So this integral of square root of a squared is a. This is tan squared theta from Pythagorean identity. 1 plus tan squared is sec squared. So sec squared minus 1 is tan squared theta, which is tan theta, the square root, times a tan theta sec theta d theta. So this is equal to, bring out the constant, which is a squared. We have tan squared theta sec theta d theta so we use Pythagorean identity again. We split up this. This is sec squared theta minus 1 times sec theta d theta, and this is equal to, we open up, this is sec cube theta minus sec theta d theta. So we are still going. So sec theta plus ln sec theta plus tan theta. So y integral of sec is ln sec theta plus tan theta. So plus k. So this is equal to half this a squared. Half times that is half tan theta sec theta. Half times this is plus half of this minus this. So we now have minus half ln sec theta plus tan theta. Plus k. You get this minus half times this is plus, so half minus 1 is minus half. So that's how we got this. And we can factor the half. So I have a squared over 2 tan theta sec theta minus ln sec theta plus tan theta plus k. So again, we need to move it from theta to x and a. So from our triangle, right angle triangle, we said let x equal to a sec theta. So let's use it and get the remaining. So if x is a sec theta, meaning that sec theta is x over a. So if this is theta, meaning that cos is a over x. So a x. So cos theta, sec is x over a, cos is now a over, and so the remaining here will be square root of x squared minus a squared. So tan theta, tan is now opposite, which is x squared minus a squared over a. So let's substitute here. Therefore the integral is a squared over 2 of tan theta is square root of x squared minus a squared over a, y sec theta is x over a, that's from here, is x over a, minus ln of sec theta is x over a, plus tan is square root of x squared minus a squared over a plus k. So we finish it up, a squared over 2. This is now x times x squared, square root of x squared minus a squared over a. Y, this is len, since the LCM is a constant, so the len of constant is also a constant, so I have x len of square root of that plus s squared minus a squared plus k. Remember, this half, this is the product. So what am I trying to? Okay, so we now generalize that the integral of anything of this form, remember they gave us plus or minus. So let's bring everything together. Therefore, we can now generalize that the integral of this is always equal to a squared over 2 times x squared plus or minus a squared over a squared minus plus or minus len x plus square root of x squared plus or minus a squared plus k. Assuming we're asked to evaluate this, so assuming we're asked to evaluate these integrals, let's close this. Okay, the first one, so we have integral of square root of x squared plus a is 2, so 2 squared dx. Our answer is a squared, which is 4 over 2, then bracket x times, since we have plus, we have x squared plus 4 over 4 plus len x plus square root of x squared plus 4 plus k. So that's the answer is now, this is 2 times x squared plus 4 plus len x plus square root of x squared plus 4 plus k. So that's the answer for the first one. While the second one, we have square root of x squared minus 25, which is 5 squared. So in this case, a is 25 over 2 times x square root of x squared minus 25 over 25 minus len x plus square root of x squared minus 25 plus k. So that's it. So whenever you have this integral, that is the formula. Thank you.